Hi, check out what landed on my bench again. This is another piece of equipment from Agilent. Recently I've made a video repairing a system DC power supply model 6612C, and this unit is quite similar to that one. This is model 66309D, and it's called Mobile Communications DC Source. This is a dual supply with some special features suitable for testing battery-powered devices like mobile phones, let's say, with some spiky load, so it has fast transient response and stuff. So this was even cheaper. I paid around $100 with shipping, so I simply couldn't resist. Obviously it was sold for parts and repair. As you can see, the knob is missing and keyboard is pushed in, which was not, by the way, visible on the eBay's page on the pictures. Let me turn it around. This thing is quite heavy. So that plastic bezel is also missing here. It's broken, which is not a big deal. If I manage to repair the thing, I can buy another one on eBay. I've seen they are sold there for some $15 or so. Alright, so this guy doesn't have terminals on the front panel. Everything should be connected here on the back, and the connectors are exactly the same as that 6612C. But this time I managed to get a couple of connectors in a local electronics store. So it was described as powering on, and the pictures showed some numbers on the display, but then there was some vague description that it either has no output or it has output but doesn't hold the load, or something like that. So it was pretty vague, but anyway, the price was right, so I decided to give it a try. Here, I think, is the reason. Look at this. It says 220 volts. So this is configured for higher voltage. Here we are, cover off, and I printed the page from the service manual how to configure the transformer for different voltages, and I see it is indeed configured for 220 volts. So that hopefully is the reason it doesn't work properly. And by the way, that knob, that encoder, it seems like it's not just broken off from the front. Someone actually desoldered the thing for some reason, and that's probably the reason the keyboard is pushed in. So someone removed the front panel, for some reason desoldered this rotary encoder, and then didn't put it together properly or something. Well, anyway, hopefully I can fix it. So let me reconfigure the voltage here to 120. And by the way, someone saved these two things, which are covers they stick like this. Okay, it's just some sticky thing. Well, anyway, that's good they didn't lose them. I'll put them back at some point. Here we are, reconfigured 220 volts. Let's give it a try. Something is wrong. It shows negative 0.242 volts. Let's enable the output. Well, it's getting stuck. Oh, but when I enable the output, it drops to just 0. Fine, no problem at all. Oh, I know the reason, yeah. Probably. The connector on the back, it has sense and output, and sense to output jumpers must be installed to work properly. On that other model, on 6612C, there was a button to turn off the sense to output internal connection. Here there is no button, so the external jumpers must be there. Well, let me do that. Alright, so I prepared this cable with jumpers, sense to output, and a piece of wire. Let's connect it to one of the outputs. So that output 1 is here. Okay. Let's go. Oh, still something is wrong. Negative 435, even more off from 0 and before. Let's check it out with the meter. So meter actually shows 8 millivolts. Let's turn on the output. That drops to 2 millivolts. So that looks good, but the reading on the display is off. It might be calibration thing, or something is wrong perhaps. Let me try to increase the voltage. Set it to, let's say, 5. Enter. And let's enable the output. 5 volts. No worries. And the reading here is correct as well. So I'm not sure why the reading is not quite right and the output is off. Alright, that's a little annoying to test with keyboard like that pushed in, so let me try to fix that first. I'll remove the front panel and come back. Here we are. I removed the front panel and look at this. Here and here should be hooks like this one, and they are broken off. And the encoder is clearly desoldered. Why? Well, because they probably thought this guy is dead and they needed encoder for some other unit. Okay, let me see How can I fix this? Alright, I put a couple of drops of hot glue, which can be easily removed later if I need to. This will do for now, for testing purposes, and if the thing works, or if I fix it, if it doesn't work, then I'll think of some better way and maybe find an encoder and put it in. Alright, let's do more testing then and see if it works. Okay, the keyboard is fixed for now. Let's give it a try again. Yeah, again it's reading 0.4 volts, negative 0.4 when output is off, but when I turn the output on, it's alright. I'm not sure what's going on, but let's test the rest of the stuff. Let's say we go to 10 volts. Alright, no worries, 10 volts here, 10 volts here. Let's give it some load. Alright, let's use electronic load. So the output is set to 10 volts, the output is on, so that's showing constant voltage mode. Electronic load is reading 998. So let's set some 100 milliamps for now. Okay, that works just fine. Let's go higher, 200, 300, 4, 5, works, no problems. So the maximum is 15 volts, 3 amps. So let's see, an amp, no worries. Let's go higher, 2 amps, works. 3 amps, works, no problems at all. Okay, turn the load off. So let's do full load test then. Voltage 15 and 3 amps. It works just fine. Okay, let me move the connector to the output 2. So this 1 means output 1. So let me turn this thing off. So now the electronic load is connected to output 2, which is not the same as output 1. So it's auxiliary output, 12 volts, amp and a half. So let's give it a try. So first we need to switch the channel, so the meter is on channel 2. And what we see is 45 millivolts and negative 10 milliamps when the output is off. So let's set some voltage, like and number 10 volts. Turn the output on. Shows constant current mode. Voltage collapsed and the reading is amp and a half. And the load is off. So something is wrong with channel 2. Alright, time to look around inside. I started looking around inside, and what I noticed is this resistor feels a little loose. So maybe something is wrong here, but to have a look I need to remove the bottom board, for which I probably need to remove everything. So while I'm removing boards, why don't we just look inside? So this was the control board. I just removed that, it was sitting here. So under that board we have this optional board with relays installed. That board here is for one extra input. It can measure one more channel, adjust the voltage on it, and this is the board. So here is this voltmeter board with some bodge circuitry added to it. Look at this. And here is this optional relay board. Also has some bodge wire. And there are more bodges on that bottom board. There is that wire added. So there is some circuitry added. Let me see if I can zoom in. So some bodges here. Nothing seems wrong so far, except that resistor which feels loose. But I need to remove the board to see from the bottom. Let me do that and come back. Alright, I managed to remove this board, and here is this resistor. It's clearly a current shunt. It is 0.25 ohms, a quarter ohm. Resistor must be for channel 2, because I see this, the other one, which is 0.05 ohms, so that must be for channel 1, which is 3 amp channel. And interesting that I don't see anything wrong on this side. So here is that pin, which I believe moves, and nothing looks wrong on the bottom, but here I believe I clearly see. Let me zoom in. Oops. I think I clearly see how that pin moves out of the board when I flex the resistor. I removed this part from the board because when I tried to retouch the soldering joints, it looked as if nothing is wrong with the joints, but this thing is still moving. Look at this. These two pins, they are loose inside of this resistor, so it's clearly broken. I need to go find something of this sort. So this is 0.25 ohms, 1%. Let me see if I can find something similar. I believe we cannot proceed without some kind of replacement. It's another day, and I went to a local electronics store and picked up these resistors. 0.25 ohms, 1%, 5 watts. Why did I pick up 4? Well, because I thought about arranging them like this to get 10 watts power dissipation. I found a data sheet for the original resistor. Let's have a look. So this is our CD brand. Here it is, and series is PVH 4-terminal Kelvin design to cancel lead wire effect. And in this row I found exactly these dimensions: 1/2 inch, one dimension, 0.4 another, an inch and a half long. So that's exactly this guy, and that is this PVH 7 watts. So it's slightly higher than those 5 watt ones. So I'm still not sure if I need to worry about arranging 4 of them or just put in one. However, let's look at other specs. Here is the temperature coefficient from 25 to 100 degrees C. For this range of resistance, they give 150 ppm per degree C. And I found data sheet for these 5 watt resistors. They are Vishay Dale brand, and they don't give temperature coefficient for that range of resistance, for 0.25 ohms. All they have is 90 ppm from 1/2 ohm to 1 ohm. So all I can see is just they're comparable in this sense, in the temperature coefficient. Let's assume that it's slightly higher because it goes higher and higher. So for 10 ohm range and above, they have 20 ppm. Then from 1 ohm to 10 ohm, 50 ppm. And for this low range, 1/2 ohm to 1 ohm, 90 ppm. This was rated at 150. So not sure exactly, but looks like they're similar in this sense. So should I arrange 4 of them or just put in one? Well, I thought, what's the actual power dissipation? And because I believe this is channel 2 sense resistor, which is capable of doing 1.5 amps. So what's the power dissipation? It's I squared R, which is in our case 1.5 amps squared times 0.25 ohms, and it is just slightly more than 1/2 watt. So I believe this guy was grossly oversized, and it's probably a good idea because it runs cooler, and this temperature coefficient, well, I mean, the temperature drift is much better than if it doesn't get very hot. However, on the board, this guy is sitting right next to the fan. So I really believe that one is gonna be enough. Here it is installed. I run this green sense wire to the board, and very short sense wire is also soldered there. So let's assemble the thing and test. Alright, it's back together again, except the cover. I put a piece of cardboard for now. Let's give it a try. So let's switch to channel 2. Voltage, let's say 10 volts, and enable the output. Let's dial in half an amp. Now what is half an amp? And the load also shows half an amp, no problems. So let's go to full load then. Voltage is 12, and let's go to amp and a half. There you go. No worries, it works. And let's see how hot is this resistor. I had the supply running at full load on channel 2, 12 volts, amp and a half for a while, and let's check the temperature. So I'm trying to measure around this resistor, and the maximum is 38 degrees C. Let's see, the ambient is 22. Let's check the accuracy of the repaired output to current sense. So let me switch on channel 2 to the maximum of 12 volts and turn on electronic load. So now I put the current through this Agilent 34401A multimeter, and it shows that the amp and a half is practically spot on. It's like 600 microamps or 500 microamps higher, but this reading is higher by 8.2 milliamps. So this seems to be a little higher than specs allow. According to specs, the maximum reading on the display in this mode would be 7.5 milliamps. So this is slightly higher, slightly out of spec. However, the service manual and user's guide have post repair calibration procedure, so perhaps this can be adjusted. And by the way, regarding this problem of offset on the voltage when the output is off, I read the manual, and because this guy has solid state relays option, the manual says in this case, with output disabled, the output voltage readback will not be correct. This is because sense relay is open, effectively breaking the readback path. The voltage readback will be a small negative number. Well, I'm not sure if this qualifies as small negative number. On the channel 2, this is way smaller, 48 millivolts. On channel 1 this is 241 millivolts. However, when I enable the output, and it's set to 0 volts right now, that's 0 volts exactly, so I would imagine this is not a problem at all. I went through the calibration procedure for the channel 2 current, and look at this. It is spot on. So here and here, within a few counts on hundreds of microamps. So basically it's within 1 milliamp now. That's very good, I'm happy about it. Just wanted to show how does this compare in size with the 6612C model of power supply. So this guy is quite a bit longer, and one more thing is different is that serial connector here is only for remote display, as they call it. So this thing cannot be programmed through RS-232, unfortunately, only through GPIB. And I ordered this plastic bezel, which was broken. It was 16 bucks on eBay. It will come soon. And I also found and ordered that rotary encoder. What I didn't find yet is the plastic knob which goes on that encoder. Thanks for watching. Bye.